This conference will now be recorded.
So yesterday's session, we were discussing about the scheduling options. What is node selector? What is node affinity? What is pod affinity, pod anti-affinity? Today, we'll try to discuss about taints and tolerations. What is taints and tolerations in the perspective of scheduling? So we can taint any node. Taint is like a special kind of, we are trying to add some property, kind of a marking. We can taint a node. The parts will not be scheduled in that node unless until the pod tolerates the taint. Taints and toleration. So it's kind of opposite to the node affinity. It's kind of taints is like opposite to the node affinity. Node affinity is a property of pod that attracts them to the set of nodes. Node affinity attract the pods to the set of nodes. It will attract the pods to some nodes in node affinity. Taints are like opposite. They allow a node to repel, reject. Repel is nothing but reject. They allow a node to repel set of pods. Taints. Taint is a property of not, property of a node that allow you to repel, reject set of pods unless those pods explicitly tolerates the taint. So if you see, let's connect to the Kubernetes master. Let's connect to the Kubernetes master where we have a kubectl installed. If you see, we have some nodes, right? Master node, worker node. If you see pods, by default will not get scheduled to the master. Why? If you see the master node, if you describe the master node has some taints. If you see there is one taint, unless until our pod tolerate this taint in our pod manifest, if you tolerate this one, then only pods will be scheduled to that node, whatever node it has a taint. So this master node has this taint. We are not tolerating this taint in our pods, right? Our pod manifest. So the pods are not getting scheduled in the master. So taint will have a three pods. Taint will have a three pods: key, value, and effect. Key, value, and effect. You can taint any node. You can taint whatever node you want to taint. So the taint has a three parts: key, value, effect. Key and value you can give anything. Key and value you can give anything in the taint. But effect, we have three types of effects. We have three effects here: no schedule, no execute, prefer no schedule. You can taint any node with any key and value, but effect should be either of these three. No schedule, prefer no schedule, and no execute. If I taint any node with this no schedule, if I taint any node with this no schedule effect, scheduler will not schedule a pod unless until your pod tolerates the taint. Unless until your pod tolerates the taint. If the any node has this effect, taint with this effect, pods will not be scheduled. No execute. I can add a taint with this effect, no execute. What will happen? Whatever pods which is already running in that node, if the pods are not tolerating this effect, the pods will be evicted from that node. That pods will be removed from that node. This prefer no schedule is a soft version of this no schedule. Prefer no schedule effect in the taint is a soft version of this no schedule. It will prefer the pod without matching toleration to be not scheduled on that node. But if there is no other node, it will schedule. So we can taint any node. We can taint any node. It's a property of the node. Right? If you see, as of now, master node has this taint. If you observe, whatever pods we scheduled, did those pods, whatever pods we created, did those pods got created or scheduled in the master? Whatever we created, if you observed from so far, from the beginning, no. Why it is not scheduled in the master? Because of this taint. Does any of our pods, in any of our pods, did we tolerate this effect, this taint? In our pod manifest, we have to tolerate. Did we tolerated taints? No. Right? So similarly, you can add any taint. Any node you can taint. If you see, only master node has a taint. I am describing just node, so all the nodes are getting described. Only master node has a taint, but other worker nodes doesn't have a taints. Okay? So now I can taint any node, something like this. Something like this. Key, value, and effect. You can give any key, any value, but effect should be no schedule or prefer no schedule, no execute. Right? I can taint the kubectl, taint nodes, node name, right? Key value, key value, and effect. Key is also not mandatory. You can just give a value and effect. Okay? I can taint something like this. This key can be anything. This can be ABC, this can be XYZ, but this will be no schedule, prefer no schedule, no execute. We are tainting the node, some node. So let me taint this node. So something. This is key, this is value. I hate pods, something like this. No schedule, something like this. Anything you can give. Now, if I taint this node with the effect as no schedule, what will happen to the pods which is already running in that node? Because those pods are not tolerating the taint. Existing pods. What will happen to this pod? it will not evict because the effect is no schedule. Whatever parts we will try to schedule in the future, it won't be scheduled unless until the parts doesn't tolerate. Because I'm using no schedule effect, so existing parts will continue to run, but new parts will not be scheduled unless until the part tolerates the taint. But instead of this no schedule, if I make this effect as no execute, in that case, what will happen to the existing parts already, whatever is running? It will evicted. Evicted in the sense, what is the meaning of evicting? It will remove those parts, whatever parts which is running, if it is not tolerating. Did we tolerate this taint in our pod manifest? Whatever we used? No, right? If the pod tolerates this taint, if this pod tolerates this taint, it will continue to run. So we have this effect, no schedule. Now, let me apply the taint. Now, if you see one node, so this node also, do we have a taint now? Another node, describe node. Do you see this node also? We had a taint now. We added a taint. Now, whatever pod it was running earlier, it is continue to run. It is continue to run. But now, for some reason, the pod is gone. I'm deleting the pod intentionally. Now, will it come into that node? Now I deleted the pod. It will try to reschedule, but is that pod is tolerating the taint? Will it be scheduled in 85? No. If you see, it went to pending state. It went to pending state. It is not scheduled. Why it is in pending state? Because of some issue. Taint. One node has a taint, the pod is not tolerating. One node has a taint, the pod is not tolerating. So master node has a taint, worker node also has a taint, it is not tolerating. Okay. So unless until your pod tolerates the taint, unless until your pod tolerates the taint, the pods will not be scheduled in that node. Right? Now let me show that how to tolerate. Let me delete everything. Let me delete everything. So here, guys, you already know this affinity, pod affinity, node affinity, all those things. Right? I'm trying to remove this. So now what I do, basically, I will now I will reduce the CPU also for now. Something like this. Now, if you see, I am not tolerating anything. I am not tolerating anything in our pod manifest. If I deploy this one, I'm not tolerating as of now. If I deploy this one, I created two pods. Why two pods? Both pods scheduled in the same node. Did I use node selector also? I have not used node selector also, but still, why it is scheduled in the same pod, a same node? Because now how many nodes has the taints? How many nodes has the taints in our cluster now? Two, master node and worker node. Now are we tolerating the taint in our pod manifest? No. So that's why it is not scheduled in that node. Taints will repel the pods from the nodes, okay, unless until you tolerate the taint. Now how can I tolerate? So in your pod manifest, you can mention the tolerations. You can mention the tolerations. You can mention the tolerations, something like this. Tolerations. Nodes are tainted for a simple reason, to avoid running the workload. Toleration is a simply a way to overcome a taint. So I can tolerate something like this. I can tolerate something like this. So we have a taints. We can tolerate something like this in our pod manifest. Tolerations. Something like this. Key. Your whatever key you have given, right, while tainting. I have given key as name. Operator equal, or you can use exists. Equal or exist. Operator. Value. What is the value? Hate pods. But when I tainted H, I have given small. Hate pods. Just whatever you have given. Effect no schedule. Now I am tolerating this taint. So will the whatever node it has a the taint, in that node also it will be scheduled. It can be scheduled now, right? Now let me show that. Now it is terminating in that node. It is creating in the same node, but you can, if you scale, it will try to schedule in other node also. If you for sorry name, what is the guys, the key I have given as a node here, but what is the key actually? Name. Okay, so in my toleration I have not given properly. If you see key, this key I have given as a name, not as a node. Let me apply. Now since I am using deployment with recreate, it is terminating the old pods. Now do you see, now the container is coming in 85 also. Do you see the container is coming in 85 also? Why it is coming? Because in our pod manifest, did I tolerated the taint? Whatever taint we had on that node, If I don't tolerate, will the parts will be scheduled on the node, whatever node has a taint. Now in the master, the parts are not getting scheduled. In the master, the parts are not getting scheduled because master has a taint. If I tolerate the taint, will it be scheduled in the master also? So I can tolerate multiple taints. I can tolerate multiple taints also, not only single taint. Here I can tolerate something like this. I can directly see, I can directly give a value. If the operator effect, so effect no schedule, operator I can say something like this, exists value, because master node is tainted without key, without key, just they have given a value. They have just given the value. So what is the taint master node has? That is effect. So key, value, effect, there will be three things. So key, value, effect. But master node, they have just, if this is the value till here, this is the value, this is the effect. So in our pod manifest, if I tolerate this taint, will the nodes, will the parts will be scheduled in the master also? So I am tolerating this one. I can tolerate multiple taints. I am tolerating this one. I am tolerating this one also. Right? Now let's do this. So there is key operator. So deployment operator exists value effect. Operator is exist. Operator invalid value. 1 second. So there is one thing. 1 second. Let me. There is the operator value. It is saying something wrong. I want to double check. 1 second. effect operator. Okay, I can just use effect and operator also, or I can use something like this: effect and operator, irrespective of the key and value. I can use something like this. Just I can tolerate only the effect and operator, whether it exists or not. Otherwise, I will use this one. Otherwise, I need to mention something like this. Here, if it is this one, I need to use equals. I need to use equals. Equal. If I use value, otherwise I can just mention these two. Okay. So now I am saying equal. This is the value. Now let me try to apply. Key is empty, which means all the value and all the keys. 1 second, let me. It's not a key actually. It should be a value. Okay, that's fine. So now the parts are existing parts are getting terminated. The new parts are getting created. Now if you observe, do you see in the master also it is getting created now? Because I'm tolerating the taint, whatever taint we had on the master. If you see 1.5 is a master machine, yes or no? It's scheduled in the master, right? If you see kubectl get nodes, 1.5 is a master node. I try to deploy two parts. One is coming in the master, another one is coming in the 171. This 85 had a taint. I am tolerating that one also. If I try to scale, maybe instead of two parts, if I try to scale to three parts, will it come in the 85 also? Since I am tolerating the taint as well. If I try to scale maybe to the three parts, if you say I'm tolerating that one also, I'm tolerating this taint as well, this one as well. So this taint is on the master. This taint is on another machine. Now, if I tolerate these taints, now you see, right? Since master has a more capacity, I'm getting in the master itself. If I keep scaling, kubectl scale deployment, I am trying to scale the deployment. Master has more capacity. Master has more capacity. It is coming in the master only. Master has 4 GB RAM, right? So the scheduler is trying to schedule in that node. I'm trying to just keep scaling. Master is able to accommodate lot of pods. Right? Once it has some memory, right? It will schedule in that other node also. That 85. Master is able to accommodate lot. Now, if you see here, now master has a lot of pods. Now, do you see in 85 also pod got scheduled? 85 also had a taint. 15 also had a taint. 85 also had a taint. 15 also had a taint. But since we are tolerating both in this pod manifest, do you see is the pods are getting scheduled in the that nodes, whatever nodes we have a taint, right? So this is taint. Now this is no schedule effect. No schedule effect. Suppose if I had a taint with no execute effect, what will happen? If I add a taint with no execute effect, what will happen? If I don't tolerate that effect, will the pod will continue to run in that nodes or it will be evicted? Will the pod will be continue to run on that node? If I add a taint with no execute, it will be evicted unless until your pod tolerates that. The way I am tolerating here, the way I am tolerating this one, this effect, if I tolerate that no execute effect also, in that case, will those pods will be evicted or it will continue to run? If I tolerate that no effect, no execute toleration also here, will it continue to run? If I tolerate that one, if I tolerate that one, it will continue to run. If I don't tolerate, it will be evicted. Right? Let me scale down. A lot of pods are there. Let me scale down to just 3. Now we have only 3 pods. I scale down manually. Now let me add a taint with this effect. The way I have executed a taint with no execute, similarly, no schedule. Similarly, let me add a taint with no execute effect. Okay. You can give anything, right? Key, value, effect. Okay. I'm saying this taint, no execute on the 85 node. Since we are not tolerating this effect, no execute effect, will it continue to run this part in this node? It will be evicted. If you see why it is terminating in that 85 node now, why it is terminating and why it is shifting to another node, we are not doing anything. We just added taint. Why it is terminating from that 85 node? I 85 node, I mark this as a effect as no execute. Does our pod is tolerating this taint? No. That's why it is evicted from that node. So taints are the properties of the nodes which will repel the set of pods unless until you tolerate the taint. Okay, this is how it works. These are the scheduling options we have. Now we have a few more concepts. Okay, we have a few more concepts here. Cardon, right? Maintenance, administration. What is administration basically? Suppose I have a Kubernetes cluster. I have some nodes. I want to do some kind of maintenance activity. In the node, I want to do some OS patches, right? OS patches or some maintenance activity installations without impacting my applications, my workloads. So in Kubernetes, we can make your nodes as an unschedulable, unschedulable. Unschedulable. So there are two things here. Okay, there are two things. One is a drain, another one is cardon. One is drain, another one is cardon. So what is drain? What is drain in Kubernetes, right? So if I drain the node, right, whatever parts which is scheduling in that, whatever parts which is running in that node, it will be moved to another node. It will be moved to another node, but you should not directly do the drain. You should not directly do the drain, because while you are executing drain, maybe API server try to schedule some parts, it will have some issues, right? So first you need to make the node unschedulable. First you need to make node unschedulable. Unschedulable. You need to make the node unschedulable. Then you drain the node. When you drain the node, what will happen? Parts will be moved to another node. If I make node unschedulable, existing parts will continue to run, but will API server schedule any new parts to that node? Whatever node we mark that as unschedulable, it will not do that. Here we can do the cardon. Here we can do the cardon, something like this. Kubernetes, right? So if you see in Kubernetes, we can safely drain the node. We can safely drain the node, right? kubectl drain to remove a node from the service. You can use kubectl drain to evict all of your parts from that node before you perform some maintenance on the node, before you do some maintenance activity. Okay? So we can drain something like this, kubectl drain your node name. But before doing this, you can cardon the node. Cardon. Cardon in the sense, it will first make that node unschedulable. Okay. So we have a cardon. The way you have a drain, similarly you have a cardon, administration. Okay. So here you have a cardon. You should not directly drain, right? You can do the cardon or uncardon. Uncardon in the sense, again you are making it to active, right? You can cardon the node, kubectl cardon. If I make a cardon, it will make unschedulable. If I do the uncardon, it will make again schedulable. Something like this. But guys, before that, if I want to remove the taint, whatever taint I have added on the node, what can I do? Suppose if I have some taints, suppose you want to remove those taints. Suppose you want to remove the taints, just because if you don't tolerate, it will remove. If I want to remove the taint, what I can do on that node, just use minus at the end, minus at the end, minus. Now if you see, okay, 1 second. No execute. There is one more effect, right? Two effects: no execute and no schedule. I have tainted two. Now, do I have the taints now on that node? Whatever node I marked, right? No. But don't undo the taints, guys, in the master. Don't undo, don't remove the taints on the master. Masters are basically for which purpose? Masters are basically to run your application parts, or master is to orchestrate the cluster, to control the cluster. only whatever parts, right? Like, some kind of a, you know, agent parts, some kind of a agent parts. If you want to run on the master, then you can tolerate the taint. As I already told you, if you see ViewNet is running in the master, ViewNet pod is running. The daemon set, ViewNet daemon set is created a pod in the master. The kube proxy also running in the master. But how come these are running in the master? Because these are tolerating this effect. Okay, so now let's try to understand this one. The drain. I have 3 nodes. Now I want to perform some maintenance activity. I want to perform some maintenance activity on 171. Let's assume there are some parts in the 171. Now what I can do first? What I can do first? If you see, first the node, is it unschedulable? Is it unschedulable as of now? It is schedulable. Unschedulable false is nothing but schedulable. It is schedulable. Now, does API server can schedule the parts if this node has some CPU memory? I want to perform some maintenance activity. I want to perform some maintenance activity on this node. So what I can do? I can do the car done on this node. What is the meaning of car done? I will mark that as what? First unschedulable. Car done, something like this, as I told. You car done, the node name, whatever node name, something like this. kubectl car done, node name. Sorry, there was a typo. Car done. Now I have car done that node. What is the meaning of that car done? If you describe, now is it schedulable? Unschedulable true, which means unschedulable true, which means does API server will consider these nodes to schedule the parts? No. Now the existing part is continue to run there. In the existing part is continue to run there, right? It is continue to run there. But now once I do the car done, what is the next one I will do? Drain. Drain. kubectl drain your whatever that node. Now this will be because there are some daemon sets are ignoring, there are daemon sets are running, right? You have to use this option while running that command, drain command. You need to use this hyphen ignore daemon sets, something like this. You need to use some these options, okay, to ignore the daemon sets. You need to use all these options. Okay, so now you use all these things, right? It is going to remove whatever parts which is running, but it will ignore the daemon sets. It will ignore the daemon sets because daemon sets are basically whatever parts, right? If it is a daemon set, it will not schedule to other node. But what about other parts, like whatever parts we have, like normal parts, deployments, replica set, stateful set, will it be rescheduled to another node because you are expecting 2 parts, 3 parts, or 1 part? So it will be rescheduled. It will be rescheduled if you have some other nodes. Now you see, is it rescheduled to other node? Since I am tolerating the taint in the master, I got these parts. But without having enough resources, without having enough CPU, enough memory, enough nodes, if you drain, if you cardon some node, if you drain some node, without having enough CPU, enough memory, or enough nodes in your cluster, will you be able to accommodate whatever parts which is running in this node? No, right? So make sure you should have enough nodes, enough CPU for a maintenance activity. Now, will the parts will be scheduled in this node? Whatever node I have drained, I have cardoned. What is the meaning of this one here if you see now? It is ready, but what is the meaning of here? Scheduling disabled. Since I have drained the node, existing parts also, does it move to the other node? Now can I do whatever maintenance activity I want to do in this server, like upgrading something? Once it is done, what needs to be done? Once you are done with everything in that node, what can I do again? You just execute uncardon. Uncardon. You uncardon. Again, do you see? Now this is removed. Now which means is this part is this node is ready to accept the parts now again? So this is how you can control the placements of your pods, and this is how you can mark your nodes as unschedulable for maintenance activity. Okay. So these are all the advanced topics in the Kubernetes. In the interview also they may not ask this much, okay, but I am trying to cover to the full extent of Kubernetes. Okay. Now let's try to understand another concept completely: managed Kubernetes clusters. Managed Kubernetes clusters. What is managed Kubernetes cluster? We have two types of clusters, right? Self-managed and managed. In case of self-managed, we are responsible to manage the cluster. If anything goes wrong with your control plane or your workers, who needs to take care about recovering the failure in the cluster? Ourselves. There are managed Kubernetes clusters. In the managed Kubernetes cluster, we have something like EKS, GKE, AKS, IKE, something like this. In the managed Kubernetes cluster, there is no support for load balancer out of the box. There is no support for load balancer. Sir, what is this? You said like the service itself will act as a load balancer, right? So what you are saying, there is no support for load balancer. That service will act as a load balancing within the cluster, but outside, from outside, how do you access? For end users, do we give that node IP and node port for accessing? You give node IP and node port for the end users. Do you ask no, end users to access something like this? The applications? No, right? And also, in most of the cases, our Kubernetes servers will be running in a private subnet, private servers. If it is running in a private subnet, private servers, right? Do we able to access these Kubernetes nodes from internet directly? No. Then how the routing will happen. We will use load balancer. What type of load balancer, guys? External load balancer. You already know the concept, right? Load balancing concept. If you remember, Kubernetes supports how many types of services we discussed so far? We discussed cluster IP, we discussed node port, we discussed headless. If you remember, I told there is a service called, one more type called load balancer. So this is basically external load balancer. External load balancer outside of your Kubernetes. So from internet, request goes to the load balancer, that external load balancer. That external load balancer will route the traffic to your node IP and node port. Basically your Kubernetes service, then pods. This is how it works, right? But do we have out of the box solution load balancer support in the self-managed? I mean to say, if I create a service of type load balancer, will it create a load balancer, external load balancer? No, you will not get out of the box solution. You need to set up a load balancer yourself. You need to set up a load balancer yourself. You define the routing to your nodes, right? But if I go for a managed Kubernetes clusters, if I go for a managed Kubernetes cluster, I can create a service of type load balancer. In that case, I will get the cloud load balancer. If I create a service of type load balancer in EKS, in AWS, do we have a service called ELB? What is ELB? What is ELB in AWS? Elastic load balancer. Suppose if I have a EKS cluster, or if I have a COPS cluster, if I create a service of type load balancer, I will get a elastic load balancer. That elastic load balancer route the traffic to your Kubernetes nodes on node IP and node port. Then it will route the traffic to the service to the pods. So, and also not only this one, if anything goes wrong with your control plane, your master machine or your worker nodes, will it get replaced automatically? If there is any failure in the control plane, if there are any issues in your nodes, will the nodes will be recreated? If I go for a managed Kubernetes cluster, right? Yes. So we have managed Kubernetes cluster and self-managed Kubernetes cluster. I think I already told in the interview also they will ask what version, I mean to say which Kubernetes you are using, which Kubernetes you are using, or they will ask which flavor of Kubernetes you are using, which variant, which Kubernetes variant you are using, or they may ask which Kubernetes flavor you are using. What does it mean? Their question is whether you are using self-managed Kubernetes clusters or managed Kubernetes clusters. If it is managed, which one? Whether you are using EKS, GKE. Given a chance to you, how do you decide what Kubernetes cluster we can use for our application? On which basis you will decide whether you go with self-managed, whether you go with managed, and also provided a chance, which one you will prefer? Do you prefer self-managed or do you prefer managed? Given a chance, managed. But if your client is not at all ready to host their infrastructure on the cloud, if your client is not at all ready to host infrastructure on the cloud, in that case, can I go for managed? No, right? Now, again, we have different types, right? There is one more software called COPS. one more software called K8S. But nowadays, no one is using this to set up a Kubernetes cluster. But what is this? K8S, Kubernetes Operations, is a software using which we can set up production ready, highly available Kubernetes cluster. Basically, this K8S will leverage use cloud services, like auto scaling groups, and a launch configurations. If you remember AWS, to set up the cluster. Basically, this is just a software. It is not going to manage the cluster. Basically, the K8S will just create a AWS auto scaling groups. It will create two groups. One ASG for masters or master, one more ASG. What is the full form of ASG here? I am just using short form. One more ASG for nodes. K8S will just create AWS auto scaling group. ASG is nothing but auto scaling group. ASG is nothing but auto scaling group. This K8S will create two auto scaling groups, one for master and one for workers. And also it creates two launch configurations. Instead of you are creating manually the launch configuration, because it will be very complex script. Instead of you creating a launch configuration, instead of you creating an auto scaling group, using K8S software, we can set up the cluster. It will internally create auto scaling groups, launch configurations. Once there is an auto scaling group for your master, once there is auto scaling group for your workers, then who will take care high availability of your master nodes, worker nodes? You know AWS auto scaling concept and launch configuration concept. So who will take care? The AWS auto scaling groups will take care. So this is how you can set up the Kubernetes cluster using K8S. But nowadays, most of the people are not using this one. But if you want, there is a detailed video in our YouTube channel. There is a detailed video on our YouTube channel, how to set up the Kubernetes cluster using K8S. So here you have a video, Kubernetes setup in AWS using K8S. Detailed video is there. I recommend you to go through, but most of the people are not using this one. But you will get an idea how it works, right? This video, Kubernetes cluster setup in AWS using K8S. This is kind of a managed only, but not fully managed. Now, there is a one more way of setting up a Kubernetes cluster in AWS. What is that? EKS. EKS. So now I will demonstrate the EKS. What is EKS? How to set up the Kubernetes cluster using EKS, right? We will discuss. What is EKS? What is the full form of EKS? Elastic Kubernetes Service. Elastic Kubernetes Service. Elastic Kubernetes Service is a fully managed Kubernetes service in the AWS. It's a fully managed Kubernetes service in the AWS. Similarly, the way we have a EKS in AWS, if I go for a Google Cloud, we have a GKE, Google Kubernetes Engine. If I go for a Azure Cloud, AKS, Azure Kubernetes Services, Azure Kubernetes Services. Okay. So we'll try to see how can we set up a Kubernetes cluster, EKS Kubernetes cluster. What is EKS? What are the benefits of EKS? How to set up the EKS, right? There are different ways to set up the EKS, guys. Management console. What is management console? Using management console, I can set up the EKS. That is manual. That is manual. Using console. I don't want to use console. Can I go for an infrastructure as a code like Terraform? Can I set up EKS cluster using Terraform infrastructure as a code? The way we can create a server's load balancers in using Terraform. Similarly, I can set up the Kubernetes cluster using Terraform also. Or there is a utility, there is a software called EKSCTL. There is a EKSCTL. Using that EKSCTL commands also you can set up the Kubernetes cluster. Using that EKSCTL commands also you can set up the Kubernetes cluster. So whatever way you want to set up, you can set up the Kubernetes cluster. Infrastructure as a code like Terraform, or manually using console, AWS console GUI, right? But in this session, I'll try to show the management console so that you will clearly understand what are the components will be part of EKS, how it works. If I just execute Terraform script, you don't know what and all things being created or provisioned, right? So using management console, we'll try to set up the Kubernetes cluster, EKS. So what is EKS? First of all, EKS, Amazon Elastic Kubernetes Service, is a fully managed Kubernetes service. EKS is the best place to run your Kubernetes applications. EKS is the best place to run Kubernetes application because of security, because of reliability, scalability, and availability. Because of its security, reliability, scalability, and availability. EKS can be integrated with other AWS services. EKS can be integrated with other AWS services such as ELB, load balancers, auto scaling groups, IAM, identity and access management, VPC, right? So we can integrate with other AWS services in EKS. It will make easy for you to run a Kubernetes on AWS. It will make EKS makes easy for you to run a Kubernetes on AWS without needing you to install, operate, and maintain the Kubernetes control plane. EKS makes it easy for you to run a Kubernetes on AWS without you need to install or operate, maintain Kubernetes control plane. So who will install, who will operate, who will maintain the control plane? The Kubernetes control plane, the masters. Who will maintain? The provider, the AWS. So if I go for a EKS, it's a fully managed control plane. It's a fully managed control plane What is the meaning of fully managed control plane? You don't have any control on the control plane master. Who will maintain the complete control plane, like master components like API server, scheduler, etcd, and control managers? If I go for a AWS EKS, it's completely managed by AWS. You don't have any control on the control plane. And you can't see a master nodes also in your account. The control plane, the master components will be completely owned by AWS and they will manage. You don't see a servers for your masters in your account. But in our account, customer account, I mean to say in our account, we will have what? We will have a worker nodes. Worker nodes. So AWS EKS provides a scalable, highly available control plane. AWS EKS provides scalable, highly available control plane that runs across multiple AWS availability zones. That runs across multiple AWS availability zones. Because in the background, they will not run in a single availability zone, single control plane. Why they will be running multiple control planes? I mean to say multiple masters instead of single master, single replica. And again, they are distributed to multiple availability zones in the background. Why? Because high availability. High availability. Okay. So the AWS will run your control plane in multiple AWS availability zones. So EKS will automatically manage the availability and scalability of your Kubernetes API servers. AWS will manage the availability, scalability of AWS, this Kubernetes API servers and etcd. Amazon EKS runs the Kubernetes control plane across 3 availability zones. Why they will be running in multiple availability zones, like 3 availability zones? In order to ensure high availability. High availability. And it automatically detects and replaces unhealthy masters. Suppose there is a master, there is one control plane having some issue. It will automatically detect and remove and recreate another master in the background. Now, to set up this one, what do you need? Right? An AWS account with some privileges, admin privileges. Suppose you don't have a permissions to manage EKS. We discussed IAM, guys. You know how to manage the permissions in AWS. Suppose you don't have a EKS read and write policies attached to your group or you. Will you be able to create with your own credentials if you don't have a EKS policies attached to you? No. So AWS account with admin privileges, right? And you need one instance to manage or access using kubectl. Right? Now, coming to the setup, right? It will take some time. I don't want to basically stop in between. Setup will take more than 40 minutes. Okay, now I just have a 15 minutes time. I just have a 15 minutes time. If I stop in between, if I explain again, also you'll get confused, right? I'll try to take tomorrow. Okay, the setup, how to set up a EKS Kubernetes cluster, right? From here, I'll start tomorrow. Okay, how to set up? I'll start tomorrow, right? Tomorrow will continue, guys. So Kubernetes, tomorrow I need still lot of classes. Tomorrow EKS, day after tomorrow Ingress. Then we have a RBAC. Then we have a Helm. Then we have to discuss about the Prometheus and the Grafana. Okay. So this is tomorrow. That is Wednesday. Thursday, I'll not take a class, guys. Thursday, I have housewarming ceremony in my native, my own home. So Thursday, I won't be available. Okay. So Thursday will not have a class because Thursday early morning only we have some puja in my home. So Thursday I'll not be available. Are back Friday. Helm it will take 2 days. Saturday and Monday. Oh, sorry, this ingress will be Friday. R back will be Saturday. Helm it will take 2 days. So Monday and Tuesday next week. Prometheus and Grafana Wednesday. Wednesday, if it splits to next day, maybe Thursday. So by maximum Wednesday or Thursday, Kubernetes will be done. By maximum Wednesday or Thursday, Kubernetes will be done. Then I will start with Ansible. Okay. Today is which class, guys? Kubernetes. I think today is the 15th session, right? In Kubernetes itself. Yeah. 15th, 16, 17, 18, 19, 20, 21 or 22 sessions of Kubernetes. 21 to 22 of Kubernetes. So 22 into 1.5, almost close to 35 hours we discussed. But in the syllabus copy, whatever we shared, right, we told it may take up to 25 hours or something, up to 15 classes, right? Yeah. So we try to cover this in detail, guys, so that you no need to struggle to attend the interview. So you no need to work, you no need to struggle to work once you get into a job if you know in and out of all these topics, right? So definitely it takes time. Okay, so we'll continue tomorrow. We will set up the EKS. Thursday no class. Friday, we'll continue Friday and Saturday. Then next week. Okay. Thank you, guys. Try to practice whatever we discussed so far. Right, we'll continue tomorrow with EKS setup. Thank you. I'm stopping the session for today. We'll continue tomorrow.